when we go through to our pipe installation phase, the main thing that we're going to have to pay particular attention to is the alignment of our leak detection conduits. So we've got two conduits. Ultimately, our leak detection conduit needs to be our bottom conduit. Okay, so that's our multi-strand control cable, and the top conduit is ultimately for our jacking cable. And the jacking cable is basically the low-cost return cable. So just to explain it, if we're having a pipeline that starts from point A and goes to point B, and there's no sub-branch associated with it, we'll have no jacking cable. Okay, we will have some jacking cable. We're going to have it at the very start and at the very end of the line, and the jacking cable takes the spike out of the signal. So, but in terms of this, you'll effectively become a redundant conduit in the top because the jacking cable won't need to return. So scenario 2 is we have a pipeline that comes along and it has a sub-branch. Now if it has a sub-branch, we would send the control cable down the conduit, and then we would return the jacking cable back on the top. Now the jacking cable has no signal, it just holds continuity. So when the jacking cable returns back to here, at this particular point in time, it would splice back onto the control cable and then return back to the underside conduit into our leak detection position. So just to recap, we would have leak detection coming in the bottom conduit. If we were going into a sub-branch, it would move into a sub-branch and the control cable, which is our leak detection cable, would run on the bottom till we get to our finishing point of that sub-branch. Then the jacking cable would return in the top conduit back to the sub-branch position. We would then reinstate and join back onto control cable, work into the bottom conduit, and then we're running the leak detection cable in the bottom. So we have a top and a bottom. You will never have the leak detection cable in the top. You will only ever have the jacking cable in the top. You have the bottom conduit. You will always have the leak detection cable in the bottom conduit. So, simulated world in the field. Right. When we bring in pipeline number 1, we're going to place that. Now, your pipes are sent to site with a capped end to make sure A, it stays clean, but B, we don't want any water egress into the system, or you're going to get a false positive when you commission the system. So that's your big challenge when you're doing this, particularly if it's in a wet season tropical environment where rain is pretty regular. You just need to pay a lot of attention and do a lot of work on maintaining closure of your end, because you don't want water ingressing into here, because your leak detection cable's in the bottom, and when you have accumulation of water there and you commission your system, you're going to get a lot of false positives coming up. All right, and you're going to have to dry your system. Now that you may achieve installing it without getting water in, or you may end up getting water in. If you get water in, okay, it is what it is. The system's just going to have to be dried. If you can achieve without getting any water in it, well then you're going to be able to avoid a downstream drying activity. And that could be several days of blowing dry air, which we've got a unit that you can use for that. Blowing dry air ultimately into the closed system and completely dehumidifying and completely stripping any moisture out of that system. It's a bit of work, so if you can avoid it, you want to do so. So first pipe has gone into the trench, awesome. We've knocked the cap off of this end, so we're ready to join the next length of pipe. This end we're going to leave the cap on because we obviously want to protect it from any water egress if we get rain filling up the trench, if we get any spray, any dust, whatever, it's a closure cap. It stays on until you're ready to terminate a pipe to it. This end we've knocked the cap off and we're ready to offer up our second pipe. Now in this instance there's one piece of pipe and I've just drawn a weld, and this doesn't exist yet. We're offering the second pipe in. We need to be mindful of our alignment of our conduits, right? And I would highly recommend to you have your control cable, which is your leak detection cable, at bottom dead center, 6 o'clock, because that's where your accumulation of a leak will form. And you're going to have your jacking cable, which is your dumb low cost cable, which is your return cable, will be at your 12 o'clock position. Okay, because this won't read any leak. Any leak happens, gravity will do the work. We'll put the fluid at the bottom of the pipeline and it will activate your control cable, and you'll know that you've got a leak plus or minus 100 mil where it is, using the PAL AT system that you've purchased. Okay, so we want to make sure when we fit up that this is pretty close to a line, because as you're pulling your cable, clearly you don't want to have excessive load going on the cable, transitioning from conduit A to conduit B to conduit C, conduit D. So that's the first thing that you're going to want to do. In terms of the fit up of the joint, well, you know, I'm assuming if you're watching this video, you do pipelines for a living. You fit it up in accordance with your weld procedure, your route, how you go about doing that. We've got weld procedures that you can reach out and request for guidance. But at the end of the day, your project will have your own specification, and you're going to ultimately fit in accordance with that, weld in accordance with that, and test in accordance with that. So that comes back to, I guess, the geometry of the end joint. You're going to have roughly 120 mil that's been left here for you guys to work with. All right, now these conduits here, you don't want to pinch them down, you don't really want to damage them, because you're going to be pulling cabling through that. Okay, so you'll weld your joint out, you'll do your test, and then you're basically ready to go into a cable pulling situation. So again, just reiterating, our control cable, which would be our leak detection cable, will go in the bottom, and if we've got a sub branch and we're returning, we're bringing our jacking cable back in the top. So I don't have the correct cable here at the moment, but just to simulate to you the process, you would go ahead and you would push an electrical snake down. You would attach your cable to the snake, you would retract your snake back through, and that's going to pull your cable through. Okay, now the lengths come in 12 meter lengths, so you're basically, any sort of standard 20 to 30 meter electrical snake is going to be perfect for this. You've got plenty of clearance, you've got 15 mil ID clearance in this. You'll easily push the snake down, attach your cable, pull it back. So that pulls your cable through the first length. Now, ideally, you're starting this pipeline at the start of the pipeline, and you'll ultimately go to the finish of the pipeline. But if you're bound to work section by section, you can join this cable. So you might have a section where you have to start at a particular chainage, and you'll be doing that section of chainage, and you've got works prior to that chainage and works past that chainage, but that section is all you can do at a time. That's fine. You can set the drum up, you can pull this through, and then we can join the cable. Okay, so whatever you're dealing with, you can. The more joints, the more cost. You know, each joiner I think is, you know, $80 or $90. So the less joints you have, the better. Now again, if this is purely just a main and no jacking, you're not going to have a cable in the top. You're just purely going to have your control cable in the bottom. So you will pull your control cable through like such. Now, being that this is buried, and being that you're more than likely going to get some element of water table, or you're going to have moisture associated with conditioning your fill and backfill and all that sort of stuff, you can't just direct bury this like it is. All right, and clearly with black steel or copper or whatever you might be using, you know, I mean, you're obviously got a corrosion treatment issue that you've got for your service pipe. So you are going to eventually enclose this joint with a gal wrap, and then we're going to heat shrink to vapor seal. And clearly those elements are very important to get right, because if we don't have a good vapor seal, you're going to have water table, in-ground water, penetrating your joint, and if that penetrates your joint, it's ultimately going to sit in the bottom of this casing, and it's going to hit your leak detection cable, and you're going to get a leak showing up on your PAL-AT system. So if you don't want to be forever out there having to fix that, you need to really get that part of it right. All right, as with all elements of the job. So your cable is now going to come through. If we don't protect this cable, when we do the heat shrinking process, the heat soak through the heat shrink, through the gal, may damage our cable. So what we want to do is we want to shroud our cable to give it some protection. So what we would recommend would be used is a heat resistant fiberglass sleeve. Now this is a standard Pertec part. We've got that up on our in-store literature documentation. Comes in a 25 meter roll, I'm pretty sure. So you'll just get the roll, and you're going to go ahead. This is basically how we would recommend the joint to look. And that's ultimately there. Now we're going to install one, but I'm just giving you a little bit of a close-up of that. So stainless zip tie, binding that onto the casing. You don't need to wring its neck. You don't want to overload it because the heat side will ultimately allow that to crush down. So just firmly retaining the fiberglass sleeve, but the fiberglass sleeve can still spin on here. We haven't wrung its neck, we've just retained it. Okay, so if I was to pull that out, get rid of that, what I'd be looking to do at this particular point in time is I'd just remove that frayed end. All right, so I've got a nice clean end. And I'd cut to length with just a small amount of slack. All right, so if I'm sitting on there, that's what I want. Just a small amount of slack, and I'm gonna go ahead and I'm gonna cut my heat protection sleeve. Now it goes without saying, if you're running control table and jacking cable, you're doing this to both. If you're only running control cable on the bottom, you're only doing it to the bottom. You don't need to do that to an empty conduit. Okay, so I'll try and do this so I don't obstruct your view. So what we want to go ahead and do is offer our cable up into our sleeve. So that's pushed through our sleeve now. Okay. Now our sleeve will slide onto our conduit spigot coming out. Now by rights we would have the snake ready to pull this back. We would attach that back into the snake and we would now pull that respectively back through the next conduit up to the next joint. So here now we can offer this up onto our conduit spigot. I'm sorry, I'm probably going to have to obstruct the view a little bit here. It's pretty self-explanatory, so if I obstruct the view, there's nothing special going on here. It's purely zippy tying the heat sleeve to the end. So obviously we'll bring the, make a point of getting your position right so that at the end of the day you can effectively do this in the ground. You may need to depending on how your welders are going, you may ultimately need to be doing some additional clearance under here in order to fit up your sleeve. I got on the wrong one. Sleeves in position there. Just pull it sort of finger tight. And then give it a nip up. Don't bring its neck and snap it off. So that's just going to retain our sleeve there. And then we're going to have our sleeve over here. Now obviously once you're organised and you're sort of getting a bit of momentum on, you're going to get the hang of this pretty quick. So now our control cable is sitting inside of a 1500 degree heat resistant fiberglass sleeve. So when we're getting our heat soak, because this is going to sit down onto our bottom gal wrap, we don't want to burn and damage our control cable, our leak detection cable. So that's ultimately going to provide the shielding that we require. So that part's done now. We can now ultimately move on to our vapor sealing of the joint. So you would have a gal wrap, something like this, and your gal wrap will end up coming underneath and snapping over, something like that. you'll see that you've sort of got yourself roughly 100 mil lap each side, so you want to roughly sort of centralise it. You'll put that over and we'll use a ratchet strap to tighten this up. So let's go ahead and do that. I would recommend getting it sort of top dead centre so it's easiest for you to work in the trench. Now you don't have to use the ratchet strap, entirely up to you. If you've got two guys working, you actually don't need the ratchet strap. It's quicker and easier to do it without, but if it's one guy working, he may just want to have the ratchet strap just to ensure it's tight. Now you don't need to wring its neck. The heat shrink does the work. All right, this is just sort of nipping it into position. So just make sure your alignment is reasonable, make sure your overlap is reasonable. So I'm just going to release that just to double check my overlap. So there's my good overlap. Right. So again, I'm not wringing its neck, I'm just giving it a light nip up. So now this is ready for me to fix. 3mm drill bit, top rivet gun, steel rivets, 3mm blind steel rivets. Okay, so there's no real critical set out on here, but I would be thinking about one roughly in the center and then two either side. Now your one's right into the end, you're going to end up going sort of down into the casing a little bit. Obviously, if you've got a control cable in here, you may think about going, hey, I don't want this top dead center, I'm going to orientate it a little bit just to avoid any risk of getting to your cable. So have some considerations around that. If there's no trace cable coming back through the top, there's no real risk to you. If you do have cable in the top, you might want to say, hey guys, let's make a point of sort of working more at the 1:30 to 2 o'clock mark. That way, when we're drilling through, there's no risk of interfacing with the control cable. Not the control cable, the jacking cable. So one on the end, one halfway between. Now if you set the drill bit right down into the jaw, you're going to limit how far you can push down anyway. So you're going to make sure that you can't actually get to the cable because you only have a small amount to drill. So taking some precaution around that is going to alleviate any potential damage that you could do in there. And look, you can just grab a 5-inch grinder, knock the arse out off the drill bit, and then you can really control how much you have through. And taking that additional precautionary measure is just going to alleviate any potential issues you could have later on. Okay, so our clad's installed. We've got a reasonably decent fit around there. It doesn't have to be absolutely perfect. You've got a little kick in the trench or whatever. Don't stress about that. The heat shrink is ultimately doing the work for you. You know, the heat shrink is creating your seal, right? This is just giving a substrate for the heat shrink to bond to. So we can remove that strap now. And that's what you'd be expecting to see in your ground. Now, assuming you can leave your trench open for long enough, and bear in mind, obviously, the longer it takes you to get this on, and the longer it takes you to get the heat shrink on, the more you're subjected to weather, rain, and ingress into this joint. So it's a balancing act. But if you can, within your pipeline, ideally you want to pull your cable, all right, and that could consist of your control cable, your leak detection cable on the bottom, and pulling your jacking cable on the top, if you have one, and ultimately pulling it all the way through the entire pipeline if you can, and then testing continuity. Because if you test continuity at that point in time, and you have any issues, you can deal with it. You can identify where you might have an issue, cut out a damaged section of cable, rectify that and continue on. Once you move into this phase, you're sort of going to a point of no return. You can return, it just returns with a great deal of difficulty. So if you can leave your joints open, test continuity before you move into this phase, I would recommend you do so. If you're maybe as a quality inspector, if you're coming along and you're seeing rivets in a top dead center and you know that there's a jacking cable, definitely pay to retest continuity on your jacking cable just to ensure no one's done any damage to that. Because if you damage the jacking cable, you break signal, it won't work. Okay, so you know, as a quality inspector, it certainly wouldn't be a bad idea to insist that your team are doing the rivets along here, and then I would still be looking at testing continuity before you go into the heat shrinking, because you can remove this to assist you with re-pulling cable, but on the same token, once you go to the heat shrinking phase, you're sort of moving to a point that's far more difficult and far more costly to fix. So assuming we're satisfied now, we've tested continuity, our control cable on the bottom we're happy with, we've tested for continuity, and our jacking cable on the top is likely part of the system, so it's part of that continuity test. It may or may not be though. If we've done a part section, we may have control cable on the bottom and jacking cable on the top that are not connected yet, because we haven't made it to the end of the line. They only get connected at the end of a sub-branch line. So main line control cable, sub-branch control cable on the bottom, then jacking cable back to the index main, then control cable again, right? So you can get instances where you will independently test for continuity, your control cable and your jacking cable. Please do that, make sure everything is going all right and you don't have any breaks or damage in the cable. Now we can move into the heat shrinking phase. Really important, clearly, because if we don't seal this now, groundwater enters, you're going to be constantly dealing with faults showing up on your system, and that's why everyone then eventually ignores it, because it's not worth it, because all they're getting is groundwater as a fault. So for this to work, we've got to seal this joint, all right? And this comes into our heat shrinking process. So I'm going to call it quits for a second, go have a quick drink, and then I'm going to come back and show you how to heat shrink. Okay, so heat shrink, cross-link polyethylene with a heat-activated mastic on the back. This heat-activated mastic can be contaminated, so the aim of the game is to keep the protective wrapping on that up until the point where we're ready to install. So we've got that wrap. As a guide, if for whatever reason you grab the heat shrink and you say, I wonder if it's the right length, what you're aiming for is for all the way around plus roughly 100 mil. There's a more complicated formula, but for you in the field wanting to know roughly, is my heat shrink the right length, you're looking for all the way around plus roughly 100 mil. If you got that, you're in the game. Okay. In addition to that, we want to have a leading edge on the bottom lap. So this is going to be the bottom lap, and that's the top lap. Now we want a leading edge so we can seal this properly. So if your heat shrink does not have a leading edge on it, then you need to cut it off, because it's not overly complicated. All right. So what we're going to do is start about 25 mil in and aim to go about 100 mil down. Okay, that's it. That's what we've cut off. All right, we're going to do it on both sides though. So 25 mil in. Down. Right, so now our bottom heat shrink has got its leading edge. So the basic building parts that we're going to need for this activity is our heat shrink, which we're not putting on yet, I'm just showing you. Leading edge will go to the bottom. As a general rule, you're going to want to try and overshoot the center, so your seam comes back to be top dead center. Why? Because it's just easier, right? You don't have to do that, but my advice is to do that because you'll find it easier. So you're going to want the heat shrink. You need a closure strip. Okay, now the closure strip is basically a second cross-linked polyethylene, and that basically is again with a heat activated mastic on the back. This is a bit more robust, this mastic, and less exposed to contamination, but you still don't want to kick it around the paddock. Do a reasonable job to keep it as clean as you can. And this is going to close the joint itself, so you'll see that in a second. So you're going to need both these items. You're going to need a flint gun, a wire brush, 9 kilo LPG gas bottle, and a heat torch, like such. Now, the ideal heat torch is one like this that allows you to basically idle it, because you're a little bit on off with the gas. So if you're constantly turning it on, turning it off, it's a bit of a pain in the ass. So if you can get yourself a heat gun, so you can idle this back, so you've got a small flame when you're not using it, but something that you can get to about that when you're using it goes back to an idle flame. So when you're resting that on the side of the trench, you're not incinerating everything nearby. Now, if site dictates you've got to turn it off, so be it. But if you can have it like that, it saves a lot of on-off. You'll find it just a bit easier. Okay, so I'm going to just turn this, right. So let's just start the process here. What we want to do is we want to prep this edge, and we want to prep this edge, because that's really where our mastic is going to do the most amount of work for us. In order to prep it, we could do it anyway, but if we apply some heat to this, it's going to do a couple of things. It's going to actually help us when we're applying our mastic, and it's also going to soften it so we can abrade that surface and get a really, a really good roughened edge for the mastic to bond into. So it's going to be a bit noisy. I'll stop talking and I'll just... So before we start the heat shrinking process, what we want to do is just make sure our edges have been clean. Now, the video stopped just before, so it actually has already been done, but I'm just going to re-simulate that because the video stopped. So you basically want to apply some heat, so about this much heat. And then you can give it a rub down with a wire brush. And you're just going to roughen the surface. So you're going to break the surface wax of the polyethylene to give the mastic the best chance of bonding and getting a good seal. So it needs to be done on both sides. I did it before the camera stopped, so we've abraded both sides. We're ready to move on with the heat shrink now. So if we're doing this in a trench, access is a little bit more difficult, and you're going to have to develop your technique. Unfortunately, we can't magic you the ability to apply it, but if you've got a trench wall, you're best off standing on the other side of the trench wall, and you're best off feeding into the trench wall. That's what I find to be the easiest way to go. So what you're going to do is you're just going to peel the very top edge of your mastic away. Now, if it's a hot day, this mastic will stick to this, and it can be a little bit difficult. So again, it's a bit technique driven. So you're going to sort of, what I normally do is go like this and sort of get it to flap under like that, and it flaps to a point where you can get your hands on it, and it sort of flaps down without digging in. So just to sort of show you again, I have it sort of rolled back like that, and I just sort of let it roll down this edge, and it goes whoop, and it flaps down like that, and then you can bring it up. So if you've got a trench wall there, you can still do all this. Now, at this point in time, you're going to think about peeling your mastic back, and you're going to bring this back up, and you're going to sort of overshoot to about there. Now, this is still going to be, this tab's going to be still sitting on the ground. Now, at this point in time, what I would do is look to just feather a little bit of heat onto this heat shrink just to get it to sit nicely down on the gown. So I'm just going to feather a bit of heat in. And that's just going to activate my mastic, and I'm just going to use the back of my wire brush just to sort of rub this edge down. Do you want to just bring that around here, Adam? Just get a little bit of a close-up of this. So I'm just sort of applying a bit of heat there and rolling that edge down. So that's got a nice bond there, and now I'm going to just give that a gentle hit, and I'm going to roughen this surface up again, because that's just going to help my mastic bond again. So now I've got a nice roughened up surface there, and I've got my mastic sort of pre-stuck down here. At this point in time, this will be laying down in the trench. You're just going to peel that through. Now, you're not looking to go as tight as you can, but you don't want it excessively loose, or it's going to make it difficult for you to get rid of the wrinkles. So don't wring its neck, just gently bring it up onto it. Now, there's a little bit of slack down the bottom here, but not a massive amount of slack. The more slack, the more difficult it is to get rid of the wrinkles. So you need to sort of get that right balance. And then we're just going to feather some heat into here. And we're just going to press this back onto itself. Always the way, the phone wants to ring when we're doing a video. So, at this point in time, we're ready to do our closure wrap. If we give this surface a bit of a rough, it's going to give a better purchase for our closure wrap. So, right, so that's lovely. So we've got a nicely roughed up surface there, ready for our closure wrap to go on. And now, we want to heat up our closure wrap. So, usually I would actually do this on this section of pipe here, so it's ready to bring over. But I don't have that section of pipe. But normally I would have that sitting on the pipe beside me, and I'd focus on heating one half of this closure wrap, place it down, and then heating the other half. And then, because I don't have that pipe, I'm just going to do it on the ground. So I'm going to heat one half. So I'd sort of give that a bit of a heat. Not too much heat on the heat shrink, just a little bit. Like just most of your heat on the closure wrap. Alright, and one more. That's now going to be hot enough for us to place here. So that gets a nice little tacky bond there, but this side's flappy up enough. Now I can go ahead and feather my heat under it and bring it down on this side. Start in the middle and just roll your way out with the brush. That way you're going to get it to come out. You get it to sort of lap over a little bit. You can sort of just flick it loose with your hand and tap it out with the brush. Okay. So that's our joint now. Now what we've got to do is activate the mastic through the body of the heat shrink, and particularly focus on getting a good heat around the edge, because we want to see mastic when we finish this poking. If you actually come up and have a quick little look here, you'll see the mastic starting to come out there. So we want to see that, but more all the way around. And that indicates to us that our heat shrink has shrunk down and is basically pinching on the mastic and creating our seal. Now, a lot of documents around heat shrinking tell you to go like that. And that's fine, but I tend to find you get a lot of bubbles. So what I actually like to do is I like to go this way. And I find it works a lot better. So what I would recommend you do is start on your bottom. give your bottom a bit of a heat. Just give it a second now just to start to contract. All right, so you're just going to stop for 10 seconds. And then you're going to start back on the bottom and just start working your way up this side. And then we're going to go and we're going to work our way up that side. Okay, so that's pulled in nicely. You can sort of see the transition from the gal to the liner, and what we're going to start to see is as this continues to shrink back. See that mastic there? I don't know if you can see that, but that looks awesome. That's exactly what we want to see, that lovely mastic there starting to come out of that heat shrink. So that's perfect. We get a really nice seal there, and we've got the same over this other side. So that's great. Now, if you had a trench wall here, you don't need to be like, you don't need to go, oh, but that's up on a pipe stand, that's easy. Yeah, I know, but it's not too bad down on the ground. The hardest part is actually getting your wrap around without contaminating it. The torching part's pretty easy. Worth having yourself a fan set up and giving yourself a bit of ventilation in the trench, otherwise it does get hot. So that's the bottom part done. We're going to restart the bottom on this side. So that's it, the heating part's done. What we want to do is just do a little press down on our ends. And you should be able to see the mastic starting to come out from under the cross-linked polyethylene casing, right? That's the adhesive mastic there, and that's getting an awesome bond onto that casing pipe. So that's giving us a perfect seal there. Now, if you get a couple of little bubbles form in here, don't worry about it, okay? Like, you don't want huge bubbles ideally, but a couple of small bubbles in there, this heat shrink will continue to contract and it will pull down on there, and it will ultimately push any of that air back into the casing, and it will tighten up. And if you end up with a small little pocket void in there, it doesn't really matter, all right? Because it will pull tightly back down on the casing when it fully contracts. What you're worried about is having full continuous mastic exposure here. So if you look at this, you can see mastic all the way around. That's what you must have, all right? This mastic edge showing is effectively your visual indicator that you have got yourself a seal. No seal there, water starts coming in, you start getting leaks, all right? You're looking at your closure. You want your closure pulled down nicely. You want your ends nicely down, you want your ends nicely down, you want to see the mastic, right? So as you can see here, there's mastic all in there, nicely squeezed out, and we've got ourselves a really good, nice closed joint. So that's the heat shrinking part. Now what I'm going to go ahead and do is I'm going to get the grinder and I'm going to cut a little patch open here so we can have a bit of a look inside. Alright, and I want to sort of give you an idea of the importance now of why we want to have that heat shield on our cable that's sitting inside here, so we know that we're not damaging our cable inside. Okay, so we'll stop here. I'm just going to get a grinder, I'm going to cut a patch and then we'll come back. A viewing patch into here just to give us a bit of a look inside of what we're doing. So you can see our heat resistant fiberglass sleeve there. Okay, our cable's through that, so you can see if you're pulling the cable, that's pulling through freely. Now it's important to understand with our control cable and with our jacking cable, it's recommended no more than 120 meters to be pulled at any one time. So if your pipeline is, let's just say 500 meters long, you need to break it up into 120 meter increments. So let's just say you couldn't leave that all exposed. You might have to bury X amount of joints, but you would need to leave a joint free for sort of a feed assist pull, and you're just going to have to ultimately armco that out and protect that, that exposed joint. So every 120, you're going to be pulling more cable if you were to sort of keep feeding off a main drum. So let's just say you were going to come off a main drum, every 120 meters you're basically going to be pulling some through and feeding, and then someone's going to be another 120 meters down and they're going to be pulling through respectively as well. Okay, so in this instance when we're looking inside, we've only got our control cable on the bottom because we don't have any jacking cable coming back at the top. If we had the jacking cable, that would be sitting down. Now if we were to have a leak in here, our control cable sits down there, that's going to pick that leak up. Respectively along the length of our conduits, at every 500 mil we've got holes drilled in the conduit, so if for whatever reason we were to have a localized leak at some point through the line, that will ultimately activate inside of a relative spacer, because we have spacers at every 700 mil supporting the pipeline. It will activate the leak detection cable in that zone, so you're going to have relatively good accuracy when it comes up on the system where you have a leak and where you need to go looking. Okay, so the importance of this sleeve is when we're heating the heat shrink, we don't want to run the risk of any heat penetration coming through and damaging our control cable or our jacking cable. Okay, and you can see now that if you were pulling more cable through, you have free, easy pull. That may not be the case trying to go back through the sleeve, so I strongly recommend you're very controlled in the way you're pulling, because once you pull past, back feeding through may not be as simple. So you're pulling off the drum in one direction. At that point in time, you're joining that and continuing pulling additional cable through. Okay, that's it.